Mark is coming from Mars, and I want to show you a little bit about his work.
Pets play an important role in our lives, but sadly, 1 out of every 4 dogs is going to develop cancer at some point in their lifetime.
Let me give you a quick overview of the inference pipeline. The biopsy is placed onto a slide, and a scanner converts this into a digitized image. We leverage torch vision to build the count or no count classifier, which is trained with thousands of examples labeled by the pathologists, and the size of mitotic figures should be counted based on whether there is cancer present in the image. The algorithm then detects where the edges of the tissue are on the image and removes the background to improve efficiency and accuracy. The image is then broken down into smaller images, and a team of fully convolutional neural networks predicts for each pixel if they belong to a mitotic figure or not. A morphological filter removes any marked pixels that do not belong to a mitotic figure by filtering for size, color, and shape. We then analyze all of the locations of the identified mitotic figures to find the region of greatest density of mitosis. These findings are then available for pathologists to access.
So I want to invite Mark to come up here as well and talk about some of the work they've done. All right, here we go.
My name is Mark Parkinson. I work for Mars Incorporated. I lead a team called the Next Generation Technologies team, which is part of the digital technologies function within Mars. When people think of Mars, what they tend to think of is the iconic brands that we have, so M&M's, Snickers, Twix. What people don't think of is Petcare, and yet Petcare is one of our huge divisions as well. So we cover things from pet nutrition, through Royal Canin. We have a big veterinary healthcare business as well. We're very lucky that we're vertically integrated. We have hospitals, we have analytics businesses. My team was set up a couple of years ago now, and our purpose is to try and drive business benefit across all of the different functions within Mars. What that starts with is looking about what is going to add impact. How do we add real business value? And how do we do it? By leveraging innovation, developing cutting-edge AI solutions, and leveraging cutting-edge platforms, products, and capabilities. We underpin that with trust because it's important to take an ethical approach to how you source your data, how you leverage your data, and to make things understandable. And ultimately, to bring these things to scale. Without scale, it's just a cool PowerPoint talking about things. To bring things to enterprise scale is a challenge. And it's not just about bringing things to scale from an architectural perspective. It's about being able to scale innovation more rapidly as well. And that's one of the key use cases for us, for PyTorch Lightning. So I mentioned that we were involved in veterinary healthcare. You saw one of our use cases earlier, which is about grading cancer automatically. There are a very limited number of specialists in the veterinary healthcare arena. Radiologists, there's about 1,200 in the world. Anatomic pathologists, even less. And so this is where leveraging AI can really help drive a business, but also help build a better world for pets. What you can see on screen is an example of one of the developments that we've worked on. One of the businesses that Mars owns is called Antech. Antech Imaging Services does telemedicine for veterinary healthcare systems. So vets, they can take their x-rays, they can submit them through and have them read. Usually takes between hours and days. When you've got a huge amount of growing demand, which is what we have from an imaging perspective from veterinary hospitals, this starts to push things out further and further. So to provide services where veterinarians get the information they need at the point they need it most in a clinic at the time when the animal is still present, we build services such as what we call Rapid Read, which allows them to submit x-rays and get results back in terms of, it's actually about 68 findings now and continuously growing, that allow them to actually evaluate what needs to be done next. What can I do that's clinically significant? Instead of taking hours and days, it now takes minutes to get results back. It's a new business service that's available, and we process actually tens of thousands of images each day now. Now, why is this relevant? Come back. And why do we use PyTorch Lightning? So it gives us a degree of abstraction. We can focus on doing more faster. We can reuse code. We can collaborate more effectively. We can focus on things like classes, data classes, etc. There's a small delta between doing an MVP. We want to try and move fast, but then actually taking that scale, it's a lot faster. We can deploy to multi-GPU systems very quickly. We can go from test and learn to getting things ready for enterprise practice, order of weeks. It's easy to integrate. We've got callback, monitoring, metrics, etc. And a simple thing, documentation and video explanations are actually really useful. There's a lot of cool tools out there, but if nobody knows how to use them, they're of no benefit. So we've been refactoring the rapid read capability that you saw to leverage PyTorch Lightning. It allows us to generate more newer models for new findings that we're pushing out there to constantly enhance our production systems. It reduces our training time because we can deploy much more rapidly to much more powerful systems. Talked about rapid read, and that's an available service of veterinarians. But that bottleneck resource that I discussed as well, which is veterinary trained radiologists, how do we help them too? So something called a JustNet, which is actually on a previous diagram. So those little pictures you saw of the x-rays coming in, that's something that we do as well. What a JustNet is, it's the ability to rotate and correctly orient x-rays before they're read by radiologists. If you're a bottleneck resource, every moment is precious. And when you're doing veterinary reads, or you're doing reads for veterinarians to give them information back about animals, every click takes time, which takes away from your ability to do these reads. And so it's actually critically important to allow us to optimize the use of that bottleneck resource, e.g. these trained specialists. Now, getting specialists to label data for you can be tricky. They've already got busy day jobs. So how do you get it done? You make it frictionless and you make it quick, you make it easy. So we built here a simple simple Lightning app that we use with radiologists. They can take the images. We've subsampled from the millions that we have available. We're very fortunate with that integration that we have access to a huge amount of data. We can show them which ones we know have been adjusted by radiologists based on the fact that we track the user interface. And we can ask them to select the data. They see the predictions. So they can select an image, they can put it through, it runs the inference on the model. If it's correct, great, we've labeled it as correct, we leave it. If it's incorrect, it's flagged in the moment, the correct orientation or flipping is put in, that feeds into our labeled data set. When we hit critical thresholds, we retrain, we deploy. Very quick, very simple, only requires periodic updating from the radiologists and allows us to deploy this much, much more rapidly than we've been able to do previously. That's a very simple and quick example. We do a lot. We don't have time to go through all of it here, but if people are interested, you can see the paper and the video that you saw with the pathology work earlier. There's papers and videos out about the other work that we've done on rapid read, x-rays, etc. Now, we're really excited about what we're able to build and leverage here. Hopefully you will be too once you've had a chance to read and look at some of these. Thank you very much for your time.
Wait. Yeah, I love this work, and obviously I think it's super important. I guess I just wanted to hear a little about your experience. So when we first mentioned the Lightning apps, I know it was kind of like during the closed beta period, and maybe at first it was like, all right, I don't know what all this thing can do, because it felt a little bit maybe too good to be true type of thing. What was your experience actually, with this stuff?
So it was actually, Lightning was brought to us by one of the guys in the team. So I don't claim to be the data engineer, the data scientist. That's the guys who work for me. They brought this to my attention and said, hey, look, I think we can work with this. And outlined what it is, like, okay, well, give it a try. It's not, I've seen other tools as well. But actually, when we were able to develop the app really fast, make it very easy, quick to use, that kind of like won me over. And also then seeing the ability to train and deploy at scale much more rapidly as well. These are things that we can do, and if you throw enough heroic effort at things, you can always get something done. But if you want to work at scale faster, you need to work smarter, and this is what enabled us to do some of that as well. So it was kind of like, the guys who are actually doing it came to me and told me about this. Yeah, that's where maybe the best sort of compliment we can get is people who are making this and making it real wanted to use it.
Great, thank you.